So in this video, you're going to learn about scientific notation in standard form. You want to say at the end of the video that you can do the following things: that you can convert numbers from standard form to scientific notation, and that you can convert numbers from scientific notation into standard form. So we'll review this board at the end of the video. So when we classify numbers, we're going to talk about them being in the numerical value forms of standard form or in scientific notation. Standard form is simply all the digits of a number. The example I gave you was 23,000. So within the numerical value of 23,000, you have 1, 2, 1, 3, and 3 zeros. So scientists can more easily work with large or small numbers using scientific notation. And what is that? That's the expression of numbers in shorthand. The example I have here is 2.30 times 10 to the fourth power. So this is the same numerical value as the number up here of 23,000. So this exponent of 4 represents the 3 behind the decimal point as well as the 3 zeros that you don't see anymore. So we're going to learn about how do you get to this process from this process and vice versa. So powers of 10, they include integers of 10. So 10 to the first power here is the same thing as 10 times 1, and you know anything to the first power is going to be itself. So we have 10 here. Notice that we had 1 0 here, and our answer also has 1 0. So, or the number exponent 1 here indicates how many zeros there will be. 10 to the second power here, that's going to be 10 times 10, and our answer is going to be 100, which has 2 zeros indicated by the exponent of 2. 10 to the third is 10 times 10 times 10, and that's going to give us 1,000. This 3 indicated the 3 zeros that are in the number 1,000. So 10 is multiplied by the amount of tens indicated by the exponent, so just like what we did here. So we have the 10, there's only a 1 here, so it's going to be 10 times 1 versus this example where you have 10 to the second power, so it's 10 times 10. So that exponent indicates the multiplications of the amounts of tens. And then it's going to be written so there's only 1 digit to the left of the decimal point. So we're going to continue talking about powers of 10. This time, if you notice, our exponents are now negative. So now when I see 10 to the negative first power, that's going to indicate division. So 1 divided by 10 is going to give me 0.1, which is going to be the same thing as this 10 to the negative first power. The difference in the direction of that exponent now, my decimal that was once on the right side is now on the left. So 10 to the negative second power is going to be 1 divided by 10 times 1 divided by 10. And that's going to give us 0.01. 10 to the negative third power is going to be 1 divided by 10 times 1 divided by 10 times 1 divided by 10, which is going to give us 0.001. So with the negative exponents, 10 is divided and it's multiplied by the amounts of 10 divided by 1 according to your exponents. And the exponent is also going to tell us the number of places to the right the decimal point is going to go. So we have an example of a large number that scientists may work with. It's the mass of the sun. So it's 2,000 billion kilograms. So this number right here has 30 zeros. So how do we write this in scientific notation? So what we would do is, technically the decimal point is at the end of the 2 and the 30 zeros right here in front of the unit kilograms. So we would move that 30 spaces. So what would that look like in scientific notation? So we would get 2 times 10 to the 30th power kilograms. So this is the same number here in standard form as it is in scientific notation right here. This is much easier to write than 2 with 30 zeros. So we have an example of a small number here, and this is the mass of a proton. So you have 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 So that has 26 zeros. It's much simpler to just do the standard form of this number, which is going to be 1.673 times 10 to the negative 27th kilogram. So what you did here is you move your decimal point from this left direction to the right so that there was 1 digit in front of the decimal point. So, or to the left specifically of the decimal point. So that's how we get 1.673 times 10 to the 27th kilograms. And remember, there were 26 zeros already, and now that the decimal point is behind the 1, that's how you get the 27th power. So we're going to do some practice ourselves. Up here, you notice we're going from standard form to scientific notation, and down here we're going to go from scientific notation to standard form. So we started off with 0.00682. So we want our answer in scientific notation, so that means the answer is going to have a power of 10. So we're going to move our decimal point to the right, and that's going to be 1, 2, 3, and we're going to stop right here because we want to make sure there's only one digit to the left of the decimal point. So the decimal point would now go right here, so that gives us 6.82. And let's go back. Because we're moving to the right, our exponent is now going to be a negative number. So 6.82 times 10 to the negative 1, 2, 3 to the negative third power. And here we have 1,908. Our decimal point is currently to the right, and we're going to move it to the left, so there's only one digit in front of the decimal point. So it's going to be 1, 2, 3. So our answer is going to be 1 point, make sure you see these decimal points, 1.908 times 10. And this time, because we moved it to the left, we're actually going to get a positive exponent. And that's going to be also to the third power. So 0.00682 is equivalent to 6.82 times 10 to the negative third. And 1,908 is equivalent to 1.908 times 10 to the positive third. So now we're going to go from scientific notation to standard form, and that's going to be 3.00 times 10 to the second power, and we're going to move our decimal from the left to the right, so that's 1, 2, and our answer is simply going to be 300. And here at the bottom, we're going to move our decimal from the left to our, and if you look up here, this is the same example. We went from a very small number to a little larger number. Here we're going to do the opposite, so we're going to start here and actually go to the left. So it's going to be 1, 2, 3, 4. What is that going to look like? A 0 here. 1, 2, 3, 2, 8, 1, 5. So 2.815 times 10 to the negative fourth is the same as 0.000285. So that was 1, 2, 3, 4, if you can tell the difference. So this will get easier with more practice. Let me know if you have any questions. We'll go back to this board. You should now be able to convert standard form into scientific notation. And you should now be able to convert scientific notation to standard form. But only you know from this video and taking your notes and practicing if you can actually do that. So if not, we'll take some time to practice some more. Good luck.